Okay, hello and good morning and welcome back. We're in week 7. So let's take a look here. You're going to factor out, there's two types of factoring that I taught you. Number one is what's in common. And you always ask this one first. The second one is the difference, which means minus, of two squares. Let's take a look at this here and see what's going on. Well, this one right here has a 2 in common. Remember what you were taught? Bring down the 2 and then A, B. And then over here it's 2 times 4. And then 2 times 2 and then A, B, B, B. Okay. So here they have a 2 in common, so take a 2 out. Here they have an A in common, so take an A out. We also have a B in common, so take a B out. When you do that, you're left with A minus, and then here you're left with a 2B squared. And that's how you factor what's in common. This is called, remember, your greatest common factor. Is this part right here. All right, let's keep moving. This one right here is called the difference of two squares. Okay, first of all, it's a minus. X squared minus 4 squared, difference of two squares. So it's going to be a plus and a minus, always. So it's going to be x plus 4 and x minus 4. And you can prove that using FOIL, difference of two squares. This right here, they do want you to do FOIL, so let's do it. We're going to take this one to both of these. 3 times 3 is 9. M times M is M squared. 3M times 2 is 6M. Now move this one here to both of these. So that gives you a negative 6M and a negative 4. These cancel. So it's 9M squared minus 4. This is the difference of two squares. This one is 3M, 3 times 3, and this one is 2 squared. So it's 3M plus 2 and 3M minus 2. Difference of two squares. It doesn't matter which one comes first, the plus or the minus. I like the plus first. Okay. All right, try these. Well, let's take a look here. On this one right here, this is the difference of two squares. So it's 2x squared minus 3 squared. So it's going to be 2x plus 3 and 2x minus 3. This one right here, 8 is not a perfect square, but you can take a 2 out. 2 times 4, 2 times 9. So if you take a 2 out on that one, move the paper over a little bit. So if you take a 2 out, you're left with 4x squared minus 9. Well, now this is the difference of two squares. So that's 2x squared and then minus 3 squared. So it's going to be 2x plus 3, 2x minus 3, but that 2 is part of your answer. So make sure you bring that down. This is your whole answer right here. So you always try the greatest common factor first. Okay, last one. Yes, 16 is a perfect square, 4x. 25 is a perfect square, 5 times 5, but it's not the difference. So you can't factor this one. So this one is prime. Remember, it has to be a minus in order to be the difference of two squares. There's no such thing as the sum of two squares. Well, there is, but you can't factor it. Okay? Your assignment for today is this worksheet. So if you're at home, this is going to be worksheet A. Let me show you. Okay, so you can do it from the video if you like, but I will upload it to Canvas. And there it is. Pull that back down. There you go. All right, let's turn our attention now to geometry. This is a rhombus. And one of the properties of a rhombus, remember a rhombus is a parallelogram. And the parallelogram is OOOCD. Okay? Consecutive angles, diagonals bisect each other. But for a rhombus, the diagonals are 90 degrees. And that's real important. Now, let me show you this, okay? This line is parallel to this line because opposite sides are parallel. So this angle and this angle are equal. These are called alternating interior. So put 7x minus 6 right here. We already know this one, so take this triangle right here out. And we know it's a rhombus, so we know this one is 90 degrees. This one is now 7x minus 6. This one is 4x minus 3. You know that every triangle adds up to 180. Without knowing that these are 90 degrees because it's a rhombus, you really can't work this one. But we do know it's 90 degrees. So you're going to take 7x plus 4x gives you 11x, and then it's going to be a negative 6 and a negative 3 is a negative 9, and then you got to add that 90, so plus 90 is equal to 180. Now if you work this out, you'll get your answer, okay? So that's going to be 11x plus 81, I guess that is, equals 180, and then you're going to subtract 81 and then divide by 11, and that should give you your answer. Let's take a look here. So 180, bless me, minus 81 equals that, divided by 11. So x is equal to 9. Now if you wanted to find these angles, you would plug it back in. Okay, 4 times 9 minus 3. So again, with a rhombus, you need to know that these are 90 degrees. That gives you a triangle. These are alternating interior. Well, let's talk about dilations. On a new sheet of paper, copy this down right here. Copy down everything you see. A dilation is an enlargement. So you either enlarge it or you reduce it. Make it smaller. Okay? So it's an enlargement or a reduction. Now look here. If you want to dilate this one around this point here, we'll call that the center of dilation. And if you connect these vertices, that's what those points are, then you can draw whatever dilation you want. If you want to make it bigger, you would go this way, like this. And you would call this one A prime, B prime, and C prime. Okay? Remember, the one with the primes is the new one. Okay, so this is the pre-image, and this is the image. Make sure you know that, okay? So the ones with the primes are the new ones. If you wanted to reduce it, you would go this way. And you would make it smaller. It'd be a fraction, okay? Those are dilations. A dilation is similar to if someone shines a flashlight in your eyes. Your pupils get smaller to restrict the amount of light. So that is a reduction. But it's still a dilation. If it's dark, then your pupils get bigger to let more light in. And that also is a dilation, but that is an enlargement. Okay, let's take a look at this one right here. Example 2. Okay, now this is a lot to copy down. So just look up here and watch. Okay? All right, so a dilation keeps the angles. Now remember, the ones with the prime are the new one, okay? So this one's getting bigger. So if you look here, this is an enlargement. And notice that all the points are on those lines there, okay? So you started with this one. This is called the pre-image. And you ended up with this one, which is called the image. Okay, so this is getting bigger, so it's an enlargement. Let's see how much bigger. So this side is 2 boxes. This side is 2, 4, 6. It looks like 6 boxes. So it's getting bigger. It's a dilation of 3, and that's how you write that. So you would multiply by 3. Let's try that. Okay, well, we don't have an x and a y axis. We could say this is 0, 0, just for the heck of it. If this is the origin, then this point would be over 2, up 3. So this point would be 2, 3. So you want to multiply by 3 because it's a dilation. So multiply by 3, And when you do, your new point, your B prime, should be 3 times 2 is 6, 3 times 3 is 9. It should be over 6. Let's see if that's so. Okay. So 1, 0, 1, 2, 3, 4, 5, 6, over 6, and then up 9. And so that does work. So that's a dilation of 3. That is an enlargement. And the scale factor right here is 3. Okay, so the dilation and the scale factor are pretty much synonymous here. So this is called your scale factor. Scale factor. Okay, so if it's a dilation of 3, you multiply each point by 3. You don't add. Let's take a look at example 3 here. All right, so let me think about this one. Well, let's see what's going on here. So this one started off with the x's without the prime. So this is the pre-image. This is the new one. So this is the old and new. Okay, the pre-image and the image is the way that is. Okay, so look at what's going on. It's getting smaller. So look, the original is 1, 2, 3, 4, 5, 6 boxes, and the new one is 2 boxes. Okay, so the scale factor, that should be a 2. The scale factor is a fraction. Okay, it's 2 over 6 since it's getting smaller. So the scale factor is 1/3. So it's 1/3 of the original. So it's a dilation of 1/3. Okay, it is a reduction. It is getting smaller. Okay, that's how you do your scale factor. Look at this one right here. Find the scale factor. Well, what you need to know is how much these sides are. So they're telling you that the image, because it has the little prime marks, is 18. They're telling you that right here, 18. And the pre-image is this one. So it's getting bigger. It's starting with the pre-image, and it's getting bigger. So what you want to do is put the bigger number at the top. So it's 18 over 12, which reduces to 3 over 2. That is called a scale factor. All right, let's take a look at one more. Look carefully. You got to know which one you started with. Remember, the ones with the prime are the new ones. So you started with this one, so it's getting smaller. To get the scale factor, you would look here at, you don't want to look at that side because you'd have to do the distance formula, but you want to look at this side. It's 2, and it's dropping down to 1. Okay? And since it's getting smaller, you want to put it as a fraction, okay, because it's getting smaller. So it's a 1-to-2 relationship. The scale factor is 1/2, and it is a reduction. It is getting smaller. Okay? Let's take a look at this next one here. This one right here, they're telling you that they want a dilation of 3. See that D3? That means you're multiplying by 3. So you take each point, like this point is -1 up 2, -1 up 2, and you multiply by 3. So times 3 and times 3. So that's going to give you a -3 and 6. So your new point here is right here. All right, let me see what I did here. They have it as over 2 down 1. So let me change that. Okay, so A is over 2. They're doing this point. I did that one. So they're going over 2 down 1. So over 2 down 1, and then you multiply by 3. So A prime would be 6 and -3, and that's what they have. Okay, so that's how you do it. It's not hard. All right. This one right here is a reduction. What are the vertices? You see how it's a D 1/4? That's a fraction. So this point, let's say point P, is over 8 up 4. So put P is over 8 up 4. And the reduction, you're going to divide by 4. So divide by 4. And P prime should be over 2 and then up 1. So this point is going to be over 2 up 1, and this would be P prime. And you got to do that for each one of these. Okay, like this one is negative 4 up 0, and then you're going to divide by 4. So your new point is going to be 4 divided by 4 is going to be 1. So that's going to be a negative 1 and then up 0, because 0 divided by 4 is still 0. So negative 1 up 0 is here. So R prime is here. Okay, so we're getting a reduction here. We need to get this one. This one is 10, 11, 12. So over 12 and then down 1, 2, 3, 4. So down 4. You're going to divide by 4 because it's a reduction. Divide by 4. When you do, you're going to get 3 and negative 1. So over 3. So 1, 2, 3, down 1 is here. So Q prime is here. And if you look, this point or this triangle is going to look like this. So Q prime is going to look like that. So you start it with this big one. Notice how the angles are the same. So a dilation, the angles stay the same, but the sides are proportional. So sides are proportional. Copy that down. That's it. Those are dilations. And that's what you're going to be doing today. All right. So for today's work, I want you to start, and I have it right here for you. So today's work is page 302. Page 302. Let me make sure that's right. Okay, it looks like it's page 307 rather. All right, so page 307. And I want you to do 1 through 25. Try that one. 1 to 25. Okay, I'm pretty sure this is correct. If not, we'll change it. Have a good morning.